This is UALR final exam for college algebra, problem number 62. It asks us, if possible, to find the matrix AB multiplying A times B. Recall that when we multiply A times B, we have to look at the dimensions to see if this is possible. Here we have A is a 3 by 2 matrix, and B is a 3 by 3 matrix. And the only way that this is possible is if these two numbers are equal. If the columns of the first matrix are equal to the rows of the second matrix. Since 2 is not equal to 3, since the columns of the first matrix are not equal to the rows of the second matrix, this is going to be impossible. That says impossible. State the dimension of the result. If not, write impossible. So we are going to say impossible again. 63 is another matrix product. These are pretty easy to do. I would say if there's a lot of numbers and you have to multiply two matrices, probably enter them in a calculator so that you don't make mistakes, simple mistakes. But I will walk you through multiplying this one because it's really easy because of all these zeros. So here we have A is a 3 by 3 matrix. And whoops, let's multiply. B is a 3 by 3 matrix. Because the rows and columns match up, columns of A are equal to rows of B, we're going to get A times B is going to be a 3 by 3 matrix. Those come from this number of rows and this number of columns. 3 by 3 matrix. So when we do this, we're going to take the matrix 3, 0, 0, 0, negative 6, 0, 0, 0, 5, and multiply it by the matrix 1/3, 0, 0, 0, negative 1/6, 0, and 0, 0, 1/2. We'll change colors there. When we multiply, we are going to get 3 by 3 matrix. Sorry, change colors there. And we get the first row, first column entry here by doing the first row times the first column of this matrix. And when we say multiplication, when we're doing matrix multiplication, we multiply 3 by 1/3, then 0 by 0, and this 0 by this 0, and we do that and we add all those together. So we end up with, take these off, 3 times 1/3 gives me 1, plus 0 times 0 gives me 0, plus 0 times 0 gives me 0. So that entry is just 1. Now, whoops, let's go into the eraser again. To get the second entry, I do the first row times the second column. And that's going to give me 3 times 0, which is 0, plus 0 times negative 1/6, which is 0, plus 0 times 0, which is 0. So all that just equals 0. Next, we're going to do the first row times the second column, or third column, sorry. And we get 3 times 0 equals 0, plus 0 times 0 equals 0, plus 0 times 1/2 equals 0. So again, this entry is going to be 0. Now, we're going to move to the second row in our product matrix. This time, we're going to multiply the second row in the first matrix times the first column. And we're going to get 0 times 1/3 plus negative 6 times 0 plus 0 times 0. All of that is going to be 0. Then we're going to get 0 times 0, which is 0. Negative 6 times negative 6, or negative 1/6, which is 1, plus 0 times 0, which is 0. So 0 plus 1 plus 0 makes 1 again. Then we're going to multiply the second row times the third column. 0 times 0 equals 0. Negative 6 times 0 equals 0. And 0 times 1/2 equals 0. So again, we get a 0. Now, we're going to get the third row. So we're going to multiply the third row in the first matrix. Start by multiplying times the first row. So we get 0 times 1/3 plus 0 times 0 plus 5 times 0 makes 0. Now the third row times second column, 0 times 0 plus 0 times negative 1/6 plus 5 times 0. That's a bunch of zeros. And finally, we get 0 times 0 plus 0 times 0 plus 5 times 1/2. So this is going to be 5 halves. So our product matrix is 1, 0, 0, 0, 1, 0, 0, 0, 5 halves. And the dimensions of the result matrix, we've already said, are 3 by 3. That's how we do problem number 63.